Greetings to everyone. My name is Ankit Kanwar. I'm a first year undergraduate student at IIT Delhi. My entry number is 2021 AM 10785. I am pursuing BTech in Engineering and Computational Mechanics. I will be presenting my ELP101 project. A transducer is a device that converts energy from one form to another. The process of conversion of energy from one form to another is called transduction. Transducers are often employed in various fields around us, such as automation, measurement, and control systems, where electrical signals are converted to and from other physical quantities like energy, force, etc. Types of transducers are mechanical transducers and electrical transducers. Transducers that convert physical quantities into mechanical quantities are known as mechanical transducers. Transducers that convert physical quantities into electrical quantities are known as electrical transducers. A thermocouple is an electrical transducer that converts a temperature difference into a small voltage. In my project, I will be explaining the working of condenser microphones and dynamic microphones. A microphone is a transducer that converts audio signals into electrical signals. It is also termed as a mic. There are three main types of microphones: dynamic microphones, condenser microphones, and ribbon microphones. I will be explaining the working of condenser microphones and dynamic microphones. Condenser microphones are best known for their sound sensitivity and wide frequency response. Condenser microphones use a pair of charged metal plates, one that is fixed, the back plate, and one that is movable, the diaphragm. These two metal plates form a capacitor. These are connected to a power source. Initially, the metal plates are charged up to the voltage of the power source. This is the schematic diagram of condenser microphones. As we can see, there's a front plate, that is diaphragm, and a back plate. When sound waves hit the front plate of the diaphragm, the capacitance of the system of front plate and back plate changes. Hence, the diaphragm detects subtle variations in air pressure, which make up the sound of the room, vocal, or instrument being recorded. As we know the relation between charge, capacitance, and voltage, that is Q is equal to CV, where Q is the charge on the metal plates, C is the capacitance of the system of metal plates, and V is the voltage up to which the capacitor is charged. Due to change in capacitance, the charge on metal plates also changes. This leads to a flow of current in the circuit, which generates an electrical signal. Since received audio signals are alternating, that is, they have compressions and rarefactions, the electrical signal produced is also alternating in nature. Hence, we get an alternating voltage generated, and audio signals are converted to electrical signals by condenser microphones in this manner. These are a few pictures of condenser microphones. Coming to dynamic microphones. A dynamic microphone is most often used to record vocals and sounds that come from amplifiers. They are most often the preferred mic for recording higher volume sounds and even percussive instruments. They work well with capturing sound like those of guitars, snare drums, or vocals. In a dynamic microphone, there is a thin metallic diaphragm that is attached to a coil of wire. A magnet is positioned inside the coil, which produces a magnetic field. This is the schematic diagram of a dynamic microphone. When the sound waves hit the diaphragm, the moving coil moves back and forth due to changes in air pressure and vibration of diaphragm. This leads to change in magnetic flux passing through the coil. As per Faraday's law of electromagnetic induction, a change in magnetic flux through a closed circuit induces a voltage or electromagnetic force, also termed EMF for short, in it. As the diaphragm vibrates, the coil moves back and forth and the magnetic flux through it changes repeatedly. Alternating motion of the diaphragm leads to alternating changes in magnetic flux through the coil. This produces alternating EMF in the coil. Hence, an alternating electrical signal is generated. Since EMF is induced due to motion of the coil, this induction is known as motional induction of EMF. The EMF induced in the coil is known to be proportional to the speed of motion or vibration of the coil. Hence, dynamic microphones are termed velocity sensitive. Dynamic microphones do not need a power supply, as in the case of condenser microphones. This is a picture of a dynamic microphone. And these are the sources from where I took my information in preparing my ELP101 project. Thank you.